we'll just pick out some things to print. So thingiverse.com looks like this, and you can take a minute to find something that looks relatively simple that they might want to print. I'll give you guys a spoiler alert at the end. A couple things will be printed, and they will be things that are relatively simple and small. So maybe you don't necessarily have to pick something like very sophisticated.
How do you know it? How do you find who those are? What should you search?
Oh yeah, you can search for anything that appeals to you, and you can see what pops up. Yeah, so if I search for aliens, then I'm going to get a bunch of alien guns apparently. And these are all like 3D designs that people have spent hours of their lives.
That's too much.
Oh, and I think the idea is that many of you will be printing onto fabric. I actually don't know if that's like a requirement or not. It seems like Craig was sort of orienting the last group towards printing like this. So yeah. So we'll be printing. Yeah, I mean that's the goal is to print in physical three-dimensional objects. So this is printed directly onto fabric, and so you might choose a design that lends itself to this sort of an application. But you could also print objects. There must be a demo around of some printed thing. I mean, the object like that. That's not necessarily printed on plastic. I don't think so. No. Yeah. So if there's something that you find appealing, that would not be onto that. That's okay.
It's so cool. Well, look at that. That's so adorable. Whoa, jeez.
Oh yeah. So if we print let's see. File or a .bmf file, or if failing that, a .obj. You might have downloaded a zip, in which case you can probably open up a zip. Sorry. Yeah, so download the thing, and
It just press download the files.
yeah, and then it should automatically download or open up a little dialog.
What's that going to do it?
Yeah, do it. See if it download. Cool, so the downloaded zip file, open up and make sure there is an STL, 3MF, or OBJ file.
Do we change to what we are now?
I would save the file.
Oh, right.
Yeah, and just remember, take a note of where it is saved and what it's called. Does everyone have something to say? Ready for the next step?
Yeah.
Yeah? Cool. So the first thing we're going to do is hopefully show you one or multiple green checkboxes, and then you can hit add parts. And Greg, we all have things for the Thingiverse.
Oh man,
And,
you're doing great.
All right, great. Yeah, does everyone have their object, and is it appearing in FF?
Is that bad?
Oh yeah, that is a little bad. But
We did it green tape.
oh, it just means that, I mean, you didn't do anything wrong. It just means that
Is it because it's really tiny?
that's possible. If that is the case, we can scale it to make it more realistic.
And then will they get rid of the
dimension.
exclamation mark?
Well, let's see. So it's gonna help us try to figure out what's wrong with it. And then even if it's not the size, we can scale it as need be. So first, use that first aid icon up top. And that's like the repair.
That one?
Yeah, that little red.
Beard, or you might have like little, I can't see, there's a few just hiding way down here, little like yellow lines on faces, stuff like that. That's kind of giving you an indication of where the problem might be. Sometimes the problem is with stuff inside your object, so you can't inherently see it from looking from the outside. But if you've designed the object yourself, you do kind of want to have a little bit of a look around when you get into a demo, just so you can see where the cause of that problem is. So hopefully when you come to design objects in the future, you can pay more attention to those details and make sure that hopefully it doesn't happen again. But to actually fix those problems, we can hit the run repair script in the bottom left here, and you can just run, like in my case, I'm going to try a simple repair, and hopefully that will fix.
So we do simple repair rather than default?
Yeah. Hopefully that fixes your issue.
Looks like it did.
Yeah.
Sweet.
Yeah. And if you're happy with that, hit apply repair, and you can just remove the old broken part. And in my case, it also managed to fix it. So that's,
How do you know it's fixed?
if you had the angry red exclamation mark before and you no longer do, it's a good indication.
How did you get out of the script?
You hit apply repair in the bottom left.
You know it's all about?
The old part.
Yeah. And then even if it does fix it, if you no longer have an exclamation point, that's good. But it does mean that it did fundamentally change something about the design, so it's worth rotating it, looking around, and taking a look at the modified object to make sure it's still.
One of the things you always want to pay lots of attention to is like how physically big it's going to be. Depending on the programs and stuff that you're working in prior to getting to this stage, you might end up like working in centimeters or inches or something crazy like that. And so you can see on the left-hand side here, it tells you like the length, width, and height of your object. So you just want to make sure that those numbers are actually what you want, and you can adjust the scale of your object using the scale button up at the top, which is that ball with 2 arrows on it. Screen share open, and then you can just type in the size that you want it to be. Yeah, pretty important to make sure that things are the right size. Obviously, it's really possible to design something that's giant at the time.
The 64 millimeters, 6 inches.
Huh?
64 millimeters.
64 millimeters, 6.4 centimeters.
Yeah. It's like this big. Whole bunch of
If you click on that, we get an example here. So the align button is this one just up the top here. This is align parts. And if you select, like a face that you want your object to be, it'll make that the bottom.
Whoa.
Maybe I'll
Whoa.
break.
What are you supposed to have it aligned with? Yeah, how do we go back?
Hey, yes. Yeah. We can cancel if you don't want what it needs to do.
Wait, it like went into the block. Is it
Cancel
supposed to?
it. Just cancel. Cancel. Get out.
Oh, it doesn't. It doesn't matter the relationship to the that plane. You can see it's
Oh.
just for reference.
Do we need to have it? Do we need to have it flat?
How do
You
you
just want to be picking a kind of flat face.
Right, just right click.
Control. What's hand? No, that's totally right.
Right click and drag.
Right click. Your other right. There we go. You click on the bottom of it.
Yeah, that was
and then it's
perfect.
going to like
Essentially, we just want to
Okay.
make sure that
Let's go
when
line.
it goes to.
Okay. No angry red exclamation marks to do. So we need to save out our file. What kind of file format should we save it
Identify
as?
the thing that is.
SVG?
In SVG?
No.
That was a good guess.
A DTS?
And STL.
An STL.
Wait, what does this mean?
What does it mean? I mean, SVG is scalable vector graphics. STL is something long.
It just says next to fab project files.
Do not save it as a bad project file. You
Oh
wanna
wait,
go-
am I not saving this?
You want to go File, Export, Part,
Export?
and save your part
That's
as
fancy.
an STL. You can also do it by right-clicking on the part and then Export Part as STL. Also a 3 method if you want.
That's what it stands for.
Nice.
Surface tessellation.
And once you have saved that, and you know hopefully where you saved it, we're going to open up a program called Ultimate Secura, which looks like that. If you can't see my screen and you want to, also you can go to screen.wgtn.co.nz. Full colon 8080 in your web browser of choice that is not Microsoft Edge, and you're going to see. Yup.
Let's see, does this happen when you went to
Sorry?
export?
It just doesn't work. So it just creates lots of problems pages don't like. Because it's it doesn't support
weird.
some of the
Here,
origin
just
standards
start
and
it
stuff,
over
and so
here.
like you're relying on certain bits of JavaScript and certain versions and stuff, and so it just dies horrible.
Do you mind?
Yeah.
How's it going? You got a thing in Kira?
Huh, I've never actually seen
It's
this.
looking a bit better.
Craig, you
Yo.
know what's up here?
Hopefully. Something new and exciting.
Yeah, it's just-
Oh yeah, cool, nice, good one. So sometimes when you're exporting it, you get like the angry triangle pop up, and it's asking you about optimizing your parts for tolerance. And so what it's basically saying is, in your model, maybe you use it working with scan data or something, but you've got, we know that 2 points make lines and the lines make triangles, and that's kind of how our 3D objects are formed. It's basically saying that you've got like lots and lots of points that are really, really close to each other, like maybe 0.0001 millimeters, away from each other. And so saying, do you want to merge these into one part? Because the 3D printers that we're working with, best case, are going to be accurate to like 0.05 millimeters. Anytime you see that error message, you can just be like, yes, and blindly optimize. It's only going to make your file better. Because the machines are not as accurate as the model you're creating.
And does that mean that if you're selecting a tolerance here that it should be 0.05 or is whatever they recommend?
No, whatever they've got is
Okay,
totally fine.
cool.
Yeah, you can always just blindly be like, yes, optimize the things.
I'm listening.
I get it.
It's a big one, SDR.
Yeah.
Ooh, it's so beautiful.
Sure.
It's hot and dangerous.
Oh, there it is.
You will make a pile?
So it takes your awesome 3D files that you made and like cuts it up into pieces or something 3D printers can actually make. And what can be really useful to do is change the view that you've got so you can kind of see what the printer is going to actually do. So at the moment it's just showing you like the solid view is the object that you modeled or that you downloaded. And so what we can do is with this little button in the top right corner here, we can change that to layer view and change the layer type to line type. And then you'll get this cool like color-coded, crazy weird looking object like what I've got, which shows you how the printer is actually going to make the object. So if you change it from material color to line type. Nice. You got that? Cool. And so the main and most exciting thing you can do here is that you'll notice on the right hand side there's this little bar that you can scroll up and down. And that's going to like kind of show you, what the printer's doing at screen zoom, at different stages of our print, which is really, really useful. And also kind of fun. You can make a sneak peek. Yeah. Anyway, so that can be really useful as we start changing settings in the next step to be able to see what changed. So yeah, slide that little slider to halfway through your object. That's the end.
Oh, it shows you up prints.
It's made of books. Oh, that's so cute. Oh, that's so cute.
Whoa!
Nice. We launch into everything. There are 3 settings up in the top right here that talk about kind of the physical properties of the machine that we're going to be using. So it's asking us what machine we're using, what material we're using, and what nozzle size that is. And all of those are like physical things on the actual tool. So whatever we put in the computer here has to match up with the printer that we're using in the lab. So I'll show you at the end of the session how to check for all of that. But for now, you're going to blindly believe me when I say that we need to make it an Ultimaker, which is one of the short printers. We're going to be using the material called Fab PLA and a 0.6 millimeter nozzle. right-hand side over here is a slightly intense, maybe list of kind of 12 settings or so that we're going to run through in the next 20 minutes, maybe. That control kind of how the printer will actually produce your 3D object. There are lots of settings. If you click on this little gear, it brings up the setting window for advanced settings, and you can see there's approximately 500 or so of them. So these are the ones that we think are like the bare minimum, most important for having big impacts on your print, and then you can start playing around with more advanced settings in depending on your design as they become developed. So we'll talk through each of these settings and a little bit about like what would be kind of semi-sane base numbers to start from. Sound good? Great. So without further ado then, the first setting that we have in that list on the right hand side is
The quality?
very good, thank you. That's it's layer height. So when your object is printing, it's kind of going to take your don't print cubes, make something cool, but it's going to take your cube and basically slice it into a whole bunch of layers that are however thick you set here. So if that number's really small, then obviously you get like lots and lots and lots of layers, and if that number's really large, then you have less layers. More layers equals better detail, basically, higher kind of resolution on the z-axis, on the height, at the cost of like taking longer to print, right? So same numbers for that tend to be between 0.1 and 0.3 millimeters. And importantly, it can't be any more than sort of like 80%, I guess, of your nozzle size at max.
So what's the maximum printer?
So because the nozzles are interchangeable, it depends. But if we imagine like between 0.1 and 0.3 is kind of like a good starting point. And then in the case of a 0.6 nozzle, that would be what, 0.4-ish, 0.48 would be the maximum layer height. Yeah. And if you want to get really chunky, we have larger nozzles and stuff as well. So you go to maybe 0.1, 0.2 nozzle, and use really big.
I'm just noticing now that this slider on the right actually shows you the numerical value of the layer. So you can see each layer, and thus also you can probably see as you change layer height, total quantity of lines.
Absolutely. Yeah. And you'll also notice a fairly significant change in the time as well as you increase and decrease this. Excellent. All right, what's our next thing? Wall thickness. So the wall thickness, if we're looking at our object from the top down, it's kind of setting how much plastic we're putting around the outside edge of our object to make it, nice and strong. So the thicker that we make this, obviously, the more plastic that we're gonna have in there. So the stronger the object will be, but maybe the longer it will take to print, the more it will cost because we're using more material as well. So we can see in my flower example, if you're looking at the screen here or just at the net, if I make this, at the moment you can see, oh gosh, and you accidentally drag it and everything breaks. So this red edge here is my wall thickness, and if I crank this up to be a bigger number, I just make it on the screen so it's super obvious, like 2 for example. I've now got that red edge plus 3 more layers on the inside. And so that's my kind of newly increased wall thickness. Yes. On some objects, this is super important, it's nice and strong. And on others, you can get away with a much smaller number. The key thing to be aware of here is that this wall thickness should be a multiple of the nozzle size. So, in our case, 0.6 or 1.2 or 1.8, etc., somewhere in that kind of range. And that's kind of what you'll see as we go through all of these settings, is that they're all kind of like ratios of other things. And that's like the bit that kind of catches people out sometimes. If you pick numbers that aren't nicely inside that, it can have be like weird artifacts on your print and whatnot sometimes. Cool. Kind of making sense? Tiny bit? Not at all?
Yep.
There we go. You're nodding quiet. What's the next thing?
The top bottom figures.
Top/bottom thickness. This is the same thing, but for the top and bottom of our object instead of the sides. So we can see in my flower example here. Oh gosh, well we can accidentally scale the whole thing. Man, I'm like, man, this. In my flower example, there's like a couple of solid layers before it starts doing this weird infill thing. And so that's what that's does. Now it's tiny. If we were to guess what this had to be a multiple of, any thoughts? Same, the nozzle size. So it's going to be a multiple of your layer height, as you see here. And usually you want maybe 3 layers or about 1 millimeter of plastic, kind of whatever comes first. Depends on your designs. Pretty much. Okay, that feels good. That's a good setting. And so you slide through your object and see how those change. Or try and change the numbers. Changing the numbers instead. Cool. Okay. What have we got next?
Infill density.
Infill. Very good. So the infill setting is probably like one of the most important. And also maybe the only setting that's not like a ratio of anything else. So this is how much plastic you're like, burying inside your object. So I've got my little square, maybe it's got some wall thickness to make it nice and strong. And then for the rest of my object, it builds this kind of like cross-hatched pattern inside it to hold it all together and make it rigid, but without just filling it with material. It's going to like cost lots of money.
Great example on the screen here, actually. This yellow cross-section.
Super nice. So same numbers for this tend to be somewhere between like maybe 12% and like 30-35%, somewhere in that kind of range. There's a significant diminishing return after the 50% mark in terms of strength gained. And if you're trying to make your object heavy, there are just easier, better ways to do that than like pouring in more plastic. So yeah, I definitely recommend like sliding through your object so you can kind of see halfway there and having a look at colors, different color settings, kind of manifest in your specific object. If you have objects with really thin walls, you won't see it. So like walls, you probably won't see a scroll through, whereas you can see it like really strongly here, all of that cross-hatch is the
Maybe that yellow material.
When does it
is-
appear?
If you
Does what?
just
Just
show
appear.
what's wrong? Yeah, the yellow is just the top and
What?
bottom.
Okay, I'll try briefly mention it. If I have an object that's got like either lots of pillars or maybe lots of like individual objects on my bed, when the printing nozzle is coming around and squirting out plastic, what you can tell it to do is suck that plastic back up inside the nozzle as it moves to the next object, and then like squish it back down again, and then move along and suck it up, move back along and like squirt it out again. So if you have objects, like lots of individual objects, having the retraction on means that you won't get like weird kind of leaky bits of plastic in between the two. So that can be really helpful.
Craig,
But-
can you pop off the print from the last session? Because I just noticed that it was like a retraction situation.
Oh, nice.
This is like a good example, but now I don't see it. Maybe they grabbed it.
Maybe.
Okay.
No.
Just checking.
Retraction situation. I
Yeah.
like it. So if you don't have retraction on, you can get these wispy bits all over the place.
This might be actually relevant
But
for your print.
if you have
Different show travels.
a really tiny object and you do lots of retraction, what can happen is there's a little like the filament comes through and there's a little motor
places
that
where
can slowly cut away
the
into it.
printer's going to be
And as
moving
it's
without
like
actually
constantly
printing anything, and because we have all these different pieces, there's kind of a lot of them.
through and
So
breaking
you
that
get all
plastic.
these little
So
plastic
if you have really
bits
small
on all
objects
these
that have
lines,
lots
you
of
have
like
to help
up and downs going on.
So you might try enabling retraction.
Sometimes having retraction on is bad.
Can you just?
So otherwise, like
Yeah, if
these
you have
all
like
get
derivatives,
printed
you can
in
like
addition
clean
to
up
stuff you
afterwards.
want
It just depends on your application as to whether that's a massive pain or not. Cool. Good question. So retraction. Usually yes, but sometimes no. All right. Next one.
Print speed.
Nice. So there's two things with the speed. We have the travel and the print speed. So the travel speed is just how fast it's moving around when it's like moving between your object. So if you've got multiple objects or multiple parts of an object, that's how fast it'll move around in there. You can go pretty quick, like 90 millimeters a second, kind of fast. If you've got really teeny tiny little objects or whatnot, you might want to go a little bit slower just so the printer's not vibrating around all over the place. Yeah, pretty much that. For the print speed though, you're a little bit when you're actually printing an object, you're a little bit more limited in terms of how fast you can move around while you're actually printing. Does anyone have any thoughts as to what like the limiting factor for that might be? Like what controls how fast we move? The other group got it straight away, no pressure.
Time machine.
Yeah, like a little bit. What specifically about the machine would limit how fast we can print our object? How fast we can travel? Not sure. How many of you used the laser cutter before? Yep. So when you're following a line with the laser cutter and you want it to cut all the way through, there's kind of like a relationship there around how fast you can go versus how deep you can cut, right? So with the 3D printers, there's a similar kind of relationship, and then it's how fast we can melt plastic limits how fast we can go, right? So if you have a really big nozzle and a really thick layer height, that means you're trying to melt lots of plastic at once, which means you need to go slower to allow that to happen. If you have a really small nozzle and a really small layer height, then you can print really fast because you aren't trying to melt as much plastic. So the plastic can kind of only melt at a constant speed because the little heater in there that's trying to melt it is only so big. So for like a kind of coarse print like this, a 0.6 nozzle with a layer height somewhere between 0.1 and 0.3, we're looking at somewhere between sort of like maybe 40 and say 60 millimeters a second print speed. But if you went down to a smaller nozzle, say I had like a 0.25 nozzle and I'm printing at 0.05 millimeter height, aka 50 microns, I could crank that up, be printing much more like the 70, 80 millimeters a second, almost as fast as that travel. So it just depends on how much plastic you're actually trying to churn out at a given time. Does that kind of make sense? Alrighty. What else we got?
Enable print cooling.
Enable
Print cooling?
print cooling? Yeah, pretty much always yes. It's like super situational that you wouldn't want to do that, but it's just literally some fans that are blowing on the print. Any other interesting things? Nice, yeah. So support and print adhesion. If you're printing on fabric, you really want to try avoiding support because it's going to make your life difficult as. If you're printing, if I wanted to print it upside down, like a lamp post maybe, this is my lamp post. If I tried to print this object, obviously I've got all of this stuff hanging out in midair, so as it goes through and prints it up, eventually it's going to try and put plastic in midair and that's not going to work. So support will build a structure underneath that to hold it up. But if you're printing that on fabric, it's not that great. It's really hard to print.
Probably relevant to you because there's these places here where if you try
plastic. It's just fall. Just put that first one. So if you generate support, you can see some blue stuff there. So that's going to put some extra plastic there and actually support that those covering pieces. That in the end will just tear those pieces away. It's like a thinner. It's not a different material, but it's just relatively. It's just like a scaffolded structure. It's a little skeleton that is relatively weak, and it's kind of a pain, but in a design like this is necessary. And you can take some little trimmers out of the way.
The other thing to mention is even if you have an angle, I'm going to print like a pyramid shape, if the angle is kind of 45 degrees-ish, like that's pretty safe. It might drip a little bit, but it probably won't like hang down and make movies.
Yours is kind of a good example of that, where it's unclear whether support would really be necessary, because as it comes out, it will come out a little bit with each layer, but.
And so they can put, like when I'm printing my object, if we're imagining looking from the top down, they can put like a big fat rim around the outside to help hold it down. If you're printing onto fabric, this becomes like pretty impossible to remove. So if you're printing on glass, rims can be really useful. If you're printing onto fabric, you probably want to set that to none. It also has options for like rafts and skirts and some other useful things. Rafts are pretty situational. Skirts you might want sometimes. They just puts an olive line around the outside of your object. Useful if you're printing on glass, the rest of the time not so much. Yeah. So if I was going to print your flower object as an object, having the brim on is useful because it will give it like a wider base. And material-wise, usually they'll all run PLA, and if it's not PLA, there'll be a sticker saying what it is. Cool. Sweet. So those are the three things that like have to line up with your actual file. And then we get one of our files. Who has some files?
Here.
Getting a bunch of stuff up. Nice. And so at this stage, it's going to heat up the bed and the nozzle. And we just kind of want to make sure that there's like actually material in the printer. And we also want to have a look at the back and make sure that there's like enough material on the spool at the back to print our entire object. If you're printing tiny little triangle things, not really a problem. But if your print is like 4 meters of plastic or whatever in a more significant size, how's it going, sis? You want to make sure that it's actually got enough material and isn't going to run out halfway through.
I don't know if it's worth mentioning, it might be self-evident, but heat is the
so funny.
mechanism by which all this works. So, like the metal nozzle here is very hot, and you don't want to touch it.
Nice. There's some very good advice. Do not touch the hot things.
The plate heats up, but not to such like an urgent degree. It might be uncomfortable if you were to hold your hand on it.
Yeah. As a general rule, don't put your hands inside the printer while it's doing things. It's probably
You can like see the structure, like someone can do this.
cool. What else did I want to mention? At this stage, I'd get a trendy little post-it note and write your name and the time the print is going to finish. So like the current time plus whatever it's set in Cura, not how long your print is. And the amount of material that it's going to use. So when the next person comes along, they can look at it and be like, oh, okay, cool, this print finishes at 12:30 and it's 12:50 now. Cool. With the fabric prints, obviously we don't have a design for that, but you can see the fabric print that's running at the moment. So we have fabric that's used the like kind of bulldog clips to hold it onto the bed there. So just want to be a little bit careful when you're loading that in that you keep the tension across your fabric nice. That the fabric's not drooping in a way that it could catch inside the printer. And it's also worthwhile sometimes turning off the heated bed if you have fabric that you're printing onto, which you can do by going tune and changing the option here that says bed temperature. What is it? Build plate temperature, sorry. Yeah. If you change that down to 20 degrees or whatever, then it won't get up. Cool. But for our designs, we want the bed nice and hot, and so we're kind of hoping that in the next minute they get to their target temperatures. The glass plate has to heat up to like 60 degrees, and the nozzle heats up to kind of 190 degrees or so it can take a little, especially if you're like the first person at the start of the day. Great pondering so far.
Yeah.
Any immediate questions?
I forgot the name of the material for the soles, the ones that it's
TPU.
TPU. Thank you.
Yeah, don't ask me what it stands for. Let's face it, the P is going to be like a poly something, isn't it?
Yeah.
And the U is probably a urethane.
There we go.
Wow.
Yeah. Super exciting.
But then I had to check.
Why isn't this printing out a board?
So it does like a little test in the corner first just to make sure that it's like actually extruding. So if it's doing it onto fabric, you probably want to like pull this off your fabric before it sticks.
It's yeah, that's annoying.
Maybe it's fine, or maybe it's not. Like, the whole thing with these examples is that we are trying to learn. So if it fails hilariously, that's just a great teachable moment.
Such a bracelet.
This is so great.
So at this stage, we want to make sure A, plastic is actually coming out the nozzle, B, it's actually sticking to the plate or to your material, and C, that you are in fact printing the right file. That's probably a useful thing to keep an eye on.
2 hours.
So the other thing to note, is that the numbers on the front of the screen are just like magic made up lies, which is why we get you to write the time that your print is going to finish on the post-it note. So for the print that's going for like an hour, you should actually make a post-it note and write that down just so the next person knows. Got yours, Ella?
Oh, it's so cute. What is yours? What is it?
Tiny heart.
Aww, precious. Yeah, I know.
Well, it looks very interesting.
It's still good for demonstrative purposes. But I feel like it's definitely happened to me where it's good to pay attention at the very beginning of the print. Because in cases like that where sometimes you're just like, you start printing, you're like, wait a minute.
So
This is like way bigger or way smaller than I thought. And then you can like cut it off instead of, coming back in an hour and finding an object that's way too big.
Well, it's actually gonna go. Oh no. No, it's gonna.
Yeah, we have.
Yeah, it's really
It's gonna be a
big.
nice big bracelet. It's very large.
That's very cool.
Wow.